Hey folks, Miss Rassier here. This is a flipped lesson from Algebra 2, Section 2-4 on parallel lines and perpendicular lines. I want to talk to you first about what a flipped lesson is, since this is the first one that you guys will be doing, even though you're probably doing it in the classroom. The point of a flipped lesson is that instead of your homework being practice, your homework is taking notes on some sort of item that we're working on in class. And then when you come to class, you're practicing that new thing that you've learned, okay? So the way that I do flipped lessons is every time you get some sort of note sheet, you should have this. If you don't, there should be a link on my Common Curriculum, okay, my little planner thing that you can get to from Homework Now, and print one of these out, okay, because this is the format that I'm going to follow as we do our notes today. So you'll do this, we'll do some practice in class, make sure you feel good, and then hopefully parallel and perpendicular lines will be nicely fitting into stuff we've already learned. So let's start out by talking about things we already know. All right, stick our notes right here. Okay, so we're going to start by talking about parallel lines. Now, parallel lines are something that you've already been familiar with. I know last year in geometry you probably talked about them. In fact, Mrs. Boyce said you guys did this last year, so this should be hopefully a little bit of a review. Parallel lines, if you think about it, are like train tracks. They are two lines that never cross each other. You probably already knew that, okay? So they're lines that never cross. And what that means when we're talking about writing linear equations, okay, is something a little bit more specific. If lines never cross, so for example, if I'm thinking of this, and you don't need to write this down, I'm going to erase it in a second. These two lines are increasing at the same rate. As we've been talking about linear equations, one part of all linear equations, our slope, is our rate of change. So if two lines are parallel, they have the same rate of change, same steepness, and they have to have, because of that, the same exact slope. So that's kind of our big deal for parallel. Okay, I'm going to put a star next to it, and I'm going to write parallel lines have the same slopes. So if you have two equations, you can look at those two equations. If their m's match, then clearly they're parallel lines. They have to be the exact same. Same sign, same number, same everything. Okay? So you switch things around, put them in our slope-intercept form, and you'll be able to tell if they're parallel. Now, harder than that is writing parallel lines. Okay? So let's look at our first example. Let's do one of these together. Okay? We see that we have to come up with the equation for a line that is parallel to y equals 4x plus 2 and goes through the point 0, 4. Now, think of what we just had our quiz on, writing these linear equations. Every time we need to determine what our m is and what our b is. Every single time. What's our slope? What's our y-intercept? Now, to find slope, we used to do our slope formula. y2 minus y1 over x2 minus x1. We'd get our little fraction, simplify it down, plug it in, get our b, and we'd be good to go. Well, here it's actually, if you remember this rule, less work, okay? Our m, the slope of the line that's parallel to this, if we remember our properties of parallel lines, they have the same slopes. That means I just take this 4 right here, and I'm going to copy it right down into my new equation. My new slope has to be identical to this slope if they're parallel, so all I'm going to do is take it and use it in my new equation. I didn't have to do slope formula, didn't have to do anything, all I did was steal it. Now, to get my b, my y-intercept, I'm going to be thinking in my head, y equals m. Oh, I know my m, it's going to be 4x plus b. I don't know my b. We do not use this b, okay? We're talking about a whole new line. The new line has to go through an x and a y, it has to have a slope, and its b value is going to be different than our initial one, okay? If it was the same b, it'd be the same line, and we're not dealing with the same line. We're dealing with one that's parallel to it. Okay, it's going to be next to it, have the same steepness, but not the same y-intercept. So, if I think this is an x, this is a y, see how familiar this is to what we've just been doing? I'm going to plug in my x to my equation and my y to my equation. So instead of being y equals 4x plus b, my y is going to become 4 equals my m, I already plugged it in, times my x, 0, plus b. Again, I don't know my new b. I need to keep that as a variable for the time being. I'm going to multiply these. 4 times 0 is 0. So I could subtract 0, or I could just know, well, 0 plus b is b. So what this means is that my b value is 4. Now again, question's asking, not what is the b, what is the slope, it's saying what is the equation to the line that goes through this point and is parallel to this. So the answer's got to be an equation. I'm going to put it in slope-intercept form. Y equals m, which is 4, x plus b, it's a positive 4, so I'm going to put plus 4. And this is my answer. Okay? We'll do another parallel one in a second, but before we do that, let's hop over to perpendicular, okay, and talk about our main rule there, and we'll do one example. So, perpendicular. Looking at some general notes for it. You may remember this also from geometry. Two lines that are perpendicular, they cross at exactly 90 degrees. Okay? So if I'm thinking of this in my head, if this is my x and this is my y-axis, one line could be this, the other line has to be that, and they intersect at a 90. Okay? That 90-degree symbol lets me know that it's a right angle. So, there's a special thing to memorize here also. Parallel, if we look, we think about those train tracks, right? Same slope, same steepness, same rate of change. Here, if we look at the slope of this line, okay, we can say that it's a positive slope, right? Reading it left to right, it's going up. But if we look at this line, it's a negative slope going left to right, it's going down. So we know if they're perpendicular, they're going to be opposites. And one thing that's hard to tell from this graph, this is just a little sketch, is that not only are they opposites, one's positive, one's negative, but they're opposite reciprocals. Which means that they have a different sign. If it's positive, it becomes negative. If it's negative, it becomes positive. And that the fraction is flipped. So, for example, I'll do a little example over here. Maybe you have room on the side of yours also. If you're looking at the slope of 2, its opposite reciprocal would be negative, and then we flip it. This is like 2 over 1. So it becomes 1/2. If we're thinking of the slope 2/3, its opposite is negative, and then we flip it to find the reciprocal, 3/2. This would be the slope of a line that's perpendicular to it, okay? These two lines, since our slopes would be opposite reciprocals, again, perpendicular. So that's kind of our hint here. We need to flip our fraction and change our sign, okay? A little switch and flip maybe. So, let's do one. Looking on your sheet, first thing it says that we need to do a perpendicular, write an equation to a line, perpendicular to y equals 3x minus 2, and goes through the point 6, -1. We follow the same steps we did in parallel, except when we determine our new slope, we don't just steal the slope, okay, parallel line, same slope. Instead, when we determine our new slope, we're going to look here, and we're going to say, okay, perpendicular, we need to do opposite reciprocals. We need to flip and switch the sign of our slope. So if our old one was 3, our new one's going to have to be negative. This 3 is like 3 over 1, so it's going to become 1/3. So our new slope, we found it by just looking at our old one, is going to become -1/3. Now, fractions happen. We're not going to change this fraction to a decimal. If we were to graph this line, we want our slope to be a fraction. It's rise over run. Here we'd be going down 1, forwards 3 if we were to graph it. Now, before we could graph an equation with this slope, we need to find our new b value. Again, we don't steal this one, okay? That doesn't matter. We're done with it. We don't even look at it, really. It doesn't matter. What does matter is our x value and our y value that we're going to plug in addition to our slope. So I'm thinking I need to find my b. To find my b, I'm going to do y equals m, -1/3, x plus b. Again, I don't know it. I do know an x and I do know a y, so I'm going to plug those in. So I'm going to have, instead of y equals, I'm going to have -1 equals -1/3. My x is 6 plus b. Now, here we go, fractions, everyone's favorite. I see I'm multiplying my fraction times a whole number. We practiced this in class. You guys are pretty good at it. We put our whole number over 1, and we multiply our tops and bottoms. So I notice I'm doing a negative times a positive, so my product will be negative. 6 times 1 is 6. 3 times 1 is 3. So the product here is negative 6/3. And that can be simplified. Okay? 6 divided by 3, or 6 over 3, is 2. Plus b, and then I have my negative 1 on this side. Now again, we're at a nice easy step here. I just want to get my b alone. I'm going to add 2, and now I'm left with 1 equals b. This is not my answer. I take that piece, I take my m, and again, I want to write an equation, and I'm going to write that equation in slope-intercept form. So it will be y equals my m, okay, my slope to my perpendicular line, negative 1/3, x, plus b, it's a positive 1, so I'm going to put plus 1. And this is a line that is perpendicular to this line and goes through the point 6, negative 1. Let's take a second. I'm going to erase my board, and we will do the other two examples. I want to remind you that in order to get credit for this flipped lesson, you have to have all the notes that I have here filled out on the sheet. Okay, I didn't give it to you as an optional assignment. The way that I know you have done your assignment is that you have written things out. As we do our last two, you want to write both of those out. If you want to, pause the video right now and give it a go. Okay, try it on your own, and then I'll go over it with you. All right? All right, here are our last two examples that we'll do together, and then I'll have you do additional practice in class with me to make sure that you're good to go. So let's start by doing one parallel, and then we'll go and do our perpendicular after. So I'm thinking, I see the word parallel. First thing I notice, parallel, same slope, that's what I'm starting with. I need to know my slope, and I need to know my b, and if it's parallel, I'm going to take this slope, and I'm going to steal it, okay? If it's parallel to it, same slope. So my new m is going to be negative 3, the same thing. I'm done with this now. Now I need to find my b value. In my head, I'm thinking y equals m, which is negative 3, x plus b. I know an y and I know an x, they're right here. And I'm going to just plug them in. So x is 4, so the 4 will go there. 0 for y. So 0 equals negative 3 times 4 plus b. Negative 3 times 4 is negative 12 plus b equals 0. So I'm going to add 12, and I get that my b value is going to equal 12. So I take this chunk, and I'm going to plug them in, because again, the idea is that I'm writing the equation that is parallel to this. And an equation should be in slope-intercept form. Y equals m, which is negative 3, x plus b is plus 12, okay? There is our equation. Again, I can double check it. I know it's parallel because my slopes are the same. My y-intercept's different, but I know that this y-intercept works because I found it from plugging in this point. Perpendicular, a little bit harder, same process, okay? I notice perpendicular, I think flip and switch, okay? Maybe I'll even write that on here. Flip my fraction and switch my sign, okay? I would prefer you think opposite reciprocal, which is the math way of thinking about it, but if you need some sort of hint, flip and switch might help. So here, first things first, I find my slope. I look at the old one. I notice two things. One, it's a fraction right off the bat, so I'm going to flip it. It's going to be easy. It'll be 4 over 1, which is the same thing as just 4. I notice also that it's positive. I need to switch my sign. So positive, it's going to become negative. So my new slope now is going to be this negative 4. I need to get my b. Every time I need my slope and I need my y-intercept. To find my b, I'm thinking in my head, y equals m, which is negative 4, x plus b. I know a y and an x. They are right here. So I'm going to plug in 0 for both of them. Just because I'm plugging in zeros, folks, and stuff cancels out doesn't mean that this is impossible now. I've made something that's not going to work. It is going to work. 0 is a number, okay? So these cancel. I'm left with 0 plus b, which is, like last time, the same thing as b. And over here I have 0. That just means my y-intercept is going to be at 0, okay? When we write it in our equation, y equals m, which is negative 4, x. I can't choose to put plus 0, but if I'm really simplifying down my equation to its lowest terms, it's implied that your y-intercept is 0 if there's none there. So then this becomes the equation that is perpendicular to this because it has a flipped and switched slope, and that goes through the point 0, 0, which happens to be both our x and y intercept here. Okay? So, when your notes are done, make sure you have them somewhere safe. I'll make sure to hole punch them before you get them. We'll go over this stuff in class, and hopefully it'll click more once we do some practice together. Thank you, folks. Make sure your notes are complete. Watch it again if you need to. Yeah, thanks. Have a good one.